All right, folks, I want to do an example here of finding a parametric curve of the intersection of a couple of things. And before I do that, I want to fill in the blanks in this problem. So as you can see, problem's asking me to find a parameterization of the intersection of the blank z equals 4x squared plus y squared and the blank y equals x squared. So in order to do that, first I kind of want to identify what I'm working with here. So I'm looking at this, I'm seeing a single z that's set equal to some x squareds added to some y squareds. To me, this thing on the right-hand side feels a little bit like a circle, right? And I'm noticing that if I cover up the x component, right? So if I look at it, just see z equals some crap plus y squared, that's going to be an upward pointing parabola. I do the same thing where I set the y equal to a constant, I get an upward pointing parabola in the other direction. So to me, this represents a upwardy parabolish thing. In this case, we could tell that the cross section's horizontally, right? If we set z equal to something, we don't get a circle, we do indeed get an ellipse. So this would be an elliptic. So this is an elliptical paraboloid. Oh wow, Joe. So many letters. Paraboloid. And this other thing y equals x squared, doesn't have a z in it at all. So if it doesn't have a z in it, this to me looks like parabola, right? So I'm thinking parabola, but then it got like mooshed through the z axis, right? So it's like, here's my normal plane, right? And I've got y equals x squared, so that looks like this. There's my kind of normal y equals x squared parabola. And then it's actually like extruded up and down. Oops, I erased the wrong thing there. So there's my axes, right? And I've got parabola on that side. And I'm thinking about, well, should be another one up here and another one up here and another one down here. And this is where my one-note drawing skills really look like trash. I'm sorry. But there's lines connecting these guys, and in the back, similar ribs connecting those guys. So I'm hoping what you're seeing here is a parabola kind of swept up and down. And remember, we call those cylinders. So this is a parabolic cylinder. And we can toss this in Math 3D to double check. So let's do that. Let's see. Whoops, I don't have Math 3D open. Sorry. Wait one. Okay, so here's my Math 3D. Let's see. I'm going to need two. I guess one can be an explicit surface. The other one needs to be an implicit surface. So my explicit surface needs to be 4x squared plus y squared. Oops. That's wild. That's not where the plus sign goes. Okay, so turning off my implicit surface for a second, there's my paraboloid, right? And you could see that if I sliced it horizontally, I'd get ellipses. One thing to highlight, if you turn the scaling off, that thing gets hella steep, right? I usually turn the scaling off, but you do you. And then the other one is supposed to be y. So bare y equals x squared. Oh, hey, look, there's my parabolas, and they're extruded upwards. I'm going to turn the shading off on that sucker so we can kind of see it. And I'm going to turn its opacity down a little bit so I can see through it some. Okay, so there's the kind of shape that I'm looking at. And you see this line here? Like that curve? There's something kind of funky going on right here. You see that little bend? I don't know what that's about. I sort of suspect that that's because the number of samples on this is pretty low. So let's turn it up just a little bit and see if, oh, yep, sure enough, smooths out a little bit. We'd probably turn it up higher and get it smoother, but for right now, I'm hoping you guys see this kind of, this shape here where those two hit each other. That's what I'm going to try to describe here. You can see it from the inside too if we kind of poke our head in here. It's a little hard to do that. So ultimately, I should be able to do something right here, get a parametric curve, right? I'm going to turn this guy black. I basically just want to be able to put this black curve on that intersection. So let's go see the algebra for that, because this is going to take a second. So here's the algebra and the kind of heuristic, because there's a little bit of a, I don't have an algorithm that you can go through. I just have a set of thoughts, stuff you can try. So here's the stuff I need to see, right? In the end, I need to know something like x of t is something, y of t is something, and z of t is something. Now, filling in those blanks is going to take a hot second. So the first thing I want to figure out is, okay, what depends on what? So I'm going to draw this little picture. I'm going to say z depends on x and also on y. You guys see that from my kind of function picture here? Now, I can notice that y actually also depends on x. Okay, what that means to me is x is the thing on which everything else depends, right? We could probably draw that more clearly here. So z depends on x and also on y, and y depends on x. So x is going to be the one that matters. I'm going to tend to call that the driver. So that's me thinking in terms of like computer science or programming 3D printers, right? So that's the variable that I'm going to change, and the other two are going to respond. If you're talking to a mathematician about this who wasn't a hack and a fraud, they would call it an independent variable. But like, screw those guys. I'm pretty good with that. So I've got my driver, my kind of independent variable here, and then I've got the dependent variables y and z. So what that means is that I'm going to let x of t be t. This doesn't always work, but can be a good idea. So if I let x be t, then I can notice that y is t squared. So let me go plug those in. I'm going to go back to my Math 3D here, and I'm going to plug in this guy, right? I'm going to plug in, actually, I'm just going to delete this whole thing, right? So I'm going to plug in x is t, y is t squared, and z is I don't know what, so I'm just going to put it in the xy plane. So now, if you look down this intersection, see that when I look down the intersection, I'm over top of that? Okay, cool. So I've got this right. I'm just not sure what the z is. So let's go figure out what that z is supposed to be. So if I want to know what z is, I'm going to say, okay, so z is 4x squared plus y squared. And well, what do I know? I know that y is actually x squared. So z is 4x squared plus x squared. So if I had to rewrite this, I could rewrite it as 5x squared. And if I'm letting x drive things by making it t, then z is just going to be 5t squared. So let's go plug that in. See if that worked. So instead of 0, I'm going to put in 5t squared. Boom. Intersection, just like that. Love to see it. That actually worked. And I can tell you right now that my parametric curve is kind of a parabola. You guys see that? Which is kind of reasonable. Cool. So I hope this has been sort of a, I guess we should name these. So what was my, I want you to think back because I've covered it up now. What is the name of the blue shape there? I'm going to ask you what the rainbow one is in a second. So think up those two names for me quick. Take a second. Hoping you got it here. Remember, the blue one is a parabola, but we made a cylinder out of it, right? We extruded it up and down. So that thing is a parabolic cylinder. And our other, not our curve of intersection. So I'm going to call this actually the curve of intersection. And the explicit surface, right, the rainbow one, was z equals 4x squared plus y squared. And I'm hoping you remember that's an elliptical. I can't spell. Elliptical parabola. Okay, so I hope this gives you a little flavor. Really what we want to do is kind of try to eliminate some variables. Please note, if you have something circular, you're gonna want to use cosine and sine to deal with it. So if I was intersecting this with a plane or something, I'd probably want to be thinking about driving cosines and sines around, because I'd kind of expect to get something circular or at least elliptical in that case. Don't worry, we'll get a chance to do some of those examples in class. Thanks, guys. Much appreciated.